So an example that's familiar to you. So everybody hold out your hands, watch your hands. Everybody, hopefully, and if you don't, I am sorry. Everybody should have 10 fingers, right? If you don't have 10 fingers, again, sorry. And I hope, yeah, you just work with the fingers you have. So on your hand, you have 10 fingers. What is the chance of you selecting or somebody holding a thumb finger? How do you determine that? That's what we will call a probability. You have 5 sodas in the fridge. If you close your eyes, you're reaching and you pick one. The probability of picking one of the sodas is the chance of you picking any flavor. All right. And so how do we represent this information? It's always represented as a fraction. So if you guys have your book, which you should have your books, this formula, I need y'all to copy down. And what does this formula represent? Can you guys see? Do I need to zoom in a bit? Let me know. If you prefer me to zoom in, let me do so. So it's a lot easier for you guys to see. So as I was saying, this formula is very important because probability is represented as a fraction. And you know, a fraction has a numerator and a denominator. The denominator talks about the total possible outcomes. So when we were looking at the number of fingers you have, but me ain't seen nobody type in a long time. So before I continue, y'all let me know if you hear me, please. I feel paranoid now. Yeah, I could only take, yeah, you know? Okay. All right, bless up. So as I was saying, so if we look at the first example, right? And we look at the chance of you or somebody else pulling a thumb finger, you have to look at how much thumb fingers do you have. But before you even look at the thumb finger, what you should look at is how much fingers you have in total. So in this example, guys, what would be our denominator? Our denominator would be 10 because we have 10 fingers. And because we are speaking about thumbs, how much thumbs do you have? 2. And so your answer would be 2 out of 10. Jafra, you're actually correct. You see, trust yourself. Now, what did we learn about fractions? Do I leave my fraction like this? We never leave fractions like this. So in probability, you apply the rules. You break it down to its lowest terms. So what is this broken down to its lowest terms? What do? We said 2 into itself goes once, 2 into 10 goes 5 times. So your answer is 1 out of 10, 1 out of 5, sorry. So you have 1/5 chance of selecting a thumb. Everybody understand the general concept? So step 1 is, let me just erase this, is writing out or copying down this formula. And in the meantime, I'm just going to give you guys another example. Okay. In a class, I'm going to write on the side. In a class, we have 10 girls and 5 boys. What is the probability of choosing a boy? Again, how do we represent probability? It is always a fraction. We need a denominator and we need a numerator. The denominator needs to be the total of everything. So guys, take a guess. What would be the denominator for this example? I see 10, I see 15. I only see 2 people sharing with me. What happened to everybody else? Talk to me, let me know what's up. What is the probability of picking a boy? But keep in mind, remember, the denominator is everything and everybody. So out of the class, so the denominator would be the total number of people in the class. And how much would that be? You see why I ask you all these questions? Because I want to make sure you understand the difference between the two. 15 people in the class. That means out of everybody, which is the 15, how much persons are boys? because I want to know what is the chance of picking a boy. So it's going to be 5 out of the total number of students, which is 5 over 15. What is this fraction also equal to? Because as soon as we finish this, we're going straight into CXC questions. So that's why I need everybody to participate. Excellent. It is 1 out of 3. How did we get 1 out of 3? If I break down 5 over 15, and I'm going to explain the long way, what does breakdown means? If I divide by 2 common numbers, what's common between 5 and 15? 5. So if I divide the numerator by 5, and I divide the denominator by 5, 5 into 5 goes once. 15 divided by 5 is 3. No worry. If you're lost, no worry. Just keep your mind open. So keep in mind again, what is probability? Probability tells us how likely something is going to happen. And you need to represent probability as a fraction. So before I give another example, anybody else completely lost? Talk to me and let me know, please. How everybody feeling about the general concept? Out of 10, just what you understand so far. Okay, I'm watching. So please let me know. Talk to me. Okay, so I'm gonna give you guys some general examples before we look at the CXC questions. Okay, keep in mind you have this these slides, so you could always go back and read questions, and you have extra practice questions as well. So let's do another example. Okay, Terry, let's go. Let's look at blue and red marbles. So that's the event. Miss V have marbles, but the marbles are blue and red. Okay, I have 10 blue marbles, and I have, let me see, let me do an easy one. 10 red marbles. What is the probability of picking? And you realize probability is always represented by a P, open bracket. And in here, they're going to tell you what they want you to find the probability of. So I'm going to ask you to find the probability of red. What is the probability of picking a red marble? What do we have to do? We should always remember that probability is represented as what? A fraction. So you need something to the top and something to the bottom. What is the bottom? The total events. Terry, you understand that? What does total events mean? That means all possible options. So what is the possible options we got? We got blue and we got red. So how do we find the total options? Okay. The numerator now is whatever they're talking about. So here, what I want us to find, how much red. So if I am to represent this information, my numerator going to be what? Let me start with the denominator. The denominator is going to be the total. What is the total? I got to add these two things. That's 10 plus 10, which is what? 20. So we put 20 to the bottom, and to the top, we only want to focus on selecting red. But how much reds do we have? We have 10 reds. And so my answer would end up becoming what? 1 over 2. How did I get 1 over 2? No, you just panic too fast. I don't tell you stop the punk vibes. Trust yourself. Says you need to stop panicking. So let's go. Everybody with me? Terry, you understand a little bit better? So denominator is the total of events. The numerator is what we're talking about. So let's take a look at some examples, some CXC level questions. So let me see which one I like here. Let's take a look. All of this is just practice. I want to go straight into the exam questions, to be honest with you, because this topic is relatively simple. So a question like this will come to see. This is a direct CXC question. So keeping in mind, what do we see here? We have the answers already. So we just need to see if we understand how they get these answers. So let's look at the information. This is organized data because it's in a table. Always read the heading. The scores obtained by students in a test were recorded in a frequency table as follows. I'm going to go through what a frequency table is in a few minutes, but don't focus on that. No. Frequency just tells you how often something happens. So let me ask these general questions. We see here 0 marks. How much persons got 0 marks? 1. How many persons got 4 marks? This is a question to everybody. Let's go quickly. How many persons got 4 marks? I see Cloris. All right. We're going to have to move a little faster, so I need y'all to be ready to talk to me, okay? That's correct. How many people got the maximum mark? And I asked that question like that for a reason. How many persons got the maximum mark? What number of persons got the maximum mark? Do you know the way I asked that question? Oh, which side we should be looking at? Should we be looking at the mark side or the number of students side? May I ask you which side, which mark are the highest students, you know? I say, how many students got the highest mark? So where should you have gone? You need to go look for the highest mark first, which is 5. And then how much students get 5? 10. So all of this is practicing, drilling how to think. Everybody see that? Talk to me if you understand how we got 10. Because I asked you for the maximum, how much persons got the max. So pay attention to details, okay? No problem. That's why we're doing it. All right, so we kind of understand the information provided here. Everybody understand what this table is saying now? So we got 0 to 5 marks, and each line tells us how much each mark, how much persons got each mark. Okay, so it asks us now, what is the probability that a student chosen at random scores? So first thing first, they ask us for the probability. So A, we know we need to find 2 things. We need to find a numerator and a denominator. How do we find the denominator? They ask us for how much students got 3 marks, but we need to find the denominator. How do I find the denominator? Do I add up this part or this part? So even if you get it wrong, we need to start thinking. So let's go. Left or right? Which one we need to add up? Do we add up the left or do we add up the right? That's the question. Excellent. And the reason why I'm asking these questions is because in panic mode, when students go in exam, they just panic and they just start adding and they don't make sure that what they're adding is the correct thing. You need a total students. So you obviously need to focus on this side and add it up. Get your calculators, please. Obviously, we know it's 50, but please add it up, make sure you get 50. So just confirm that you got 50. I could do this. You should be able to do this without your calculators as well, but still. All right, so we know we're going to start off with the denominator, which is 50, because what do we always put as the denominator? The denominator is always the total event. In this case, what is our event? The students who get certain number of marks. So it's total event or total frequency. You should know what frequency means. Frequency means how often something happens. So that's why we have 1, because there's only 1 time somebody got 0. We got 4 because only 4 times somebody got 1. Everybody with me so far? So how do we get the other piece of information, which is the numerator? It would be how much persons get 3 marks. So you would need to go look for which score. You would need to go in the table and look for which score. You need to look for the score 3 marks, which would be what? This row here. Where's my highlighter? It would be this row here. So our numerator would therefore have to be 10. Now, even though they didn't break it down here, you know, I can ask you to break it down because sometimes CXC award marks for that. So what would be this broken down? What's the rule whenever we have a 0 in the numerator and a 0 in the denominator? We know we could simply cancel because you always cancel what they have in common. Agreed? So even though it's 10 over 50 here, what is it really? 1 over 5. Everybody with me? Respond quickly. Let's go. Let me know if you got it. If you don't got it, say don't got it. All right. I'm watching. All right, so let's keep it moving so long. I'm still looking to see those giving me feedback. So we have here now, this is a tricky one. So I want y'all to pay attention. And this is where students does always miss a mark or don't get no marks at all because their reading comprehension is poor. So B asks us for less than 2 marks. When you look at this, they give us 5. Anybody see why it's 5? Because in this example, you're not going to be looking at only one row because you need to look at everything that is less than 2 marks. So what is less than 2 marks? 1 mark and 0 mark, right or wrong? And so how many people got between 0 and 1? You got to add 1 and 4. So you put back 50 again because this don't change. It's always over the total. And then the numerator is what they're talking about. And what did they talk about? Less than 2 marks. 1 is less than 2 marks. 0 is less than 2 marks. So we must include these two together. How do we put anything together? We add. And so that's how we get what? 5 over 50. Everybody with me? Check in. Let's go. Do you understand? And you know, for me, may want 5 over 50. So this going to become what? 1 over 10. So this would be the same thing as 1 over 10. All right, next one. Oh, great question. So somebody asks, does CXC ever ask for probability in whole number or decimals? No, we're going to tell you something. Probability is always, okay, so let's answer this question and I'll come back. I actually like that. So somebody asks if you could give your answer in decimal form. Yes, you can. Because what have we learned before? There are 3 things that are always equal. What is that? A fraction, a decimal. Anybody remember what's the third thing that they're equal to? What's the third thing that these 2 things equal to? These 3 things are always equal to each other. What's the next one? Fraction, decimal, and what's the next one? It starts with a P. Excellent. Percentage. Yep. Oh, I remember when I was teaching you consumer, we was using the 2 versions. Don't forget. Remember, we was using all 3 versions actually. Yeah, remember? Sometimes we represented it as a percentage. Then the same percentages, we represented it as a decimal and the same thing as a fraction. So for example, let's try one. 2 over 10. 2 over 10 is the same thing as well. Anybody remember? 0.2 and 0.2. How do I change 0.2 to a percentage? You always multiply by what? 100. And anytime you're multiplying a decimal by 100, you move the point twice. So we're going to end up here. So the answer is going to be what? 20%. Everybody see that? These is revision things you need to remember, you know. These 3 things, you could represent the same information in these 3 different ways. So it is acceptable, but which one you think is the easier one? Fraction is usually the easier one. Okay, everybody with me? And so just to keep in mind, how do I change 1/5 to a decimal? Anybody remember? You just plug this information in your calculator. What does this information say? Let me zoom in. What does 1 over 5 mean? 1 over 5 means 1 divided by 5. If you put on your calculator, you'd realize you would get 0.2. Right or wrong? Please check it now. You take your calculator and check it now. You need to be able to know that. If I want to change 1/10, 1/10 is easy because you know 1/10 is just 0.1. All right. Okay, so let's keep it moving. Next one. More tree or more max. So I saw somebody was talking about that before. Here, what did they ask for? 3 or more. Does 3 or more include 3? So should we start at 3 or should we start at 4? Okay, Chloe says start at 3. Do you guys agree? Yep. So that means we need to consider everything from 3 or more, which would be the highest to 5. So what am I adding? I'm going to add 10 plus 18 plus 10. So we should know 10 plus 18 is 28. 28 plus 10, 38. That's how we get 38 over 50. Somebody tell me what is 38 over 50 as a decimal. We should know what to do. What is 38 out of 50 as a decimal? So what we should be doing is putting 38 divided by 50. How much did you get? 0.76. No, I'm glad I did that. Some people calculators don't do it. Please make sure your calculator could do it. Sometimes when you put in a fraction or divide, it does give you back the fraction in its lowest terms. Okay, 7. How do you know if it's 7.6 or 7.7? What is the number after? If the number after is 5 or more, this will become a 7. If it's less than 5, it would stay a 6. Remember these things? All right, so let's check in now before we continue. How everybody feeling about probability so far? Now that we look at this CXC level question, because that's how it's gonna come. Just like that. What is the probability of this happening, or less than this, or this exactly, or more than, or less than? Manageable? 8? All right, so let's do this one and then we're moving right along. So let's look at this one. I am not going to give you your answers. I need everybody to give me their answer. So we have here the number of goals scored by a team in 30 matches. It was recorded in a frequency table. You know what frequency table is? It's just telling you how much times these things happen. How many times does 0 goal happen? How many times 1 goal happen? 2, 3, 4, 5. All right. So question number 1, A. What is the probability of the number of goals scored in the 30 matches is 4? So talk to me. Everybody share your answer. And please share your answer for yourself. Please push yourself to share your answer. You can send it to me directly if you don't feel 100% confident. That's perfectly fine. What is the probability of, look at the question here. What is the probability of scoring 4 goals? Okay, so Myrtle said 6. Okay, let me write it to the side here. Let me write down the answers. So 6. Anybody else? I get 1 over 5. Again, another 6. Anybody else? I'm watching. I need everybody to try this question for me right now. Another person said 6. Another person said 6. All right. So guess what? If you said 6, unfortunately, that's not correct. Why is it not correct? What is the first thing that I taught you guys? Didn't I teach you guys that probability is always what? Probability is always a fraction. So how will I get a whole number? Right or wrong? System error. So step one, we need to find the numerator and the denominator. So what is the numerator? What's the denominator? The denominator is always what? The total. Everybody agree? And the numerator is whatever they're talking about, the event. So in this question, what is our total? 4 plus 3 plus 5 plus 5 plus 6 plus 7. 4 plus 3, 7 plus 10, 17, 23, 30. Is that true? Somebody back check for me there. I just do a quick maths. I got 30. Is that correct? 1 plus 2 plus 2 is 4 minus 1, that's 3. Quick maths. All right, sorry about that. So we know the denominator is 30. And so we need to look at the event that we need to focus on. And they ask us for 4 goals. How much is 4 goals? 4. So we're going to look for 4 goals. 4 goals. So 6 times they got 4 goals. So it's going to be 6 out of 30. So you guys were close, but CXC would not give that to you correct if you put 6. And so we know here that this is the same thing as 1/5. So your answer is 1/5. Everybody see that? We're learning. Let's go. B. What is the probability for B? Again, we know probability is a fraction. So it's done for you already because you don't know the denominator. So what is the numerator? What is the answer for B? Less than 3. Less than 3. What is the fraction? Take a try, even if you're not confident. I didn't see what you sent, Jeffrey. Send it again. Let me see. So I see some answers there. 12 is correct. Because when they tell you about less than 3, who are less than 3? 2 is less than 3. 1 is less than 3. And 0 is less than 3. So that means I need to add up all of them here. 4 plus 3, 7. 7 plus 5 is 12. So the answer is 12 over 30. You see, Jeffrey? And we know we could break this down using what number? I could use 6 because 6 is common here. So when you divide by 6, numerator, denominator, it's going to be 2 over 5. Everybody getting a hang of it now? It's just questions we're going through. CXC questions now get any harder than this. That's it. That's all you need to remember. So let's go. C. C is 4 or more. Everybody send me your answers. 4 or more. What is the probability of getting 4 goals or more? Again, let's take it back to the formula. The probability is always a fraction. The denominator is the total. The numerator is the event. And so we know the total don't change. It's always 30. So how many people got 4 goals or more? So we would realize here, it includes 4 because they say 4 or more. So that means we need to consider 4 and we need to consider 5. 6 plus 7 is 13. Can I break this down? Who could tell me why this can't break down? And you realize what I did not add the number of goals. Because remember, this just telling us it's 4 goals, 5 goals. We need to add the frequency. Anybody could tell me why this can't break down? What type of number is 13? These are the things you need to know. 13 is a prime number. That means 13 only has 2 factors, 1 and itself. Anytime you got a prime number, it could never break down because prime numbers have nothing in common with any other number. Everybody with me? This is basic maths. All right, so that's it for probability. Out of 10, let's go. Yes, T, what's up? Yes, this is being recorded. Let me just back check because Zoom does be spazzing. Yes, it's recording. All right. I love this question because this question was a past paper question. And a lot of people didn't do so well on this question. What do you realize here? What type of diagram? Let me see if anybody remember. What type of, oh yes, you have a meeting now with the school. So I don't know if you could let your parents attend the meeting while you attend class. But either way, I could always let you know what happened in the meeting because I was supposed to be the one hosting it. But I had to tell them I can't. Excellent job, guys. This is a histogram. Not only does it say it here, I hope you were able to look at it and remember the diagram. It's similar to a bar chart. And the difference is the bar charts are next to each other. So this is a histogram, okay? Let's look at what the histogram saying. Again, each diagram always have like a title or explanation. So it says here, the histogram below shows the number of hours a group watched television during a particular event. Now, the frequency is always on the y-axis. Everybody remember that? This is the y-axis. This is the x-axis. So when you're drawing a graph, any graph, you always got to look at the x and the y. X is always horizontal. Y is always vertical. So on the y-axis, we always have the frequency, and this is something you're gonna see a lot, so you're gonna be able to remember it. Every single graph, the frequency is always on the y-axis. What does that mean? This tells you how much person's doing whatever they're talking about. So it says here again, read it again, shows the number of hours a group watched television during the day. So what does this mean? This first graph or this first bar represents the number of people who watch what? 0 TV. This one represents how much people watch 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. Everybody see that? Because you have to be able to look at this and read it. So here we see, before we even continue, let's read and see if we could understand. How many people look at 0 hours? Watch TV for 0 hours. Everybody read it and tell me what you get. Excellent, 15. How many people watch 4 hours? How many people watch 4 hours? That's a trick question. I want to see if y'all could figure it out. Let me zoom in a little bit. Excellent work. And you know why I'm very impressed? Because what I expected you to realize is that each major box, as you see, we have major boxes and we have minor boxes. Each major box represents 5. And so we need to see how much each small box is. So we divide it. Oh, you couldn't tell now? So want me to zoom in a little bit more? Okay, everybody see what I'm talking about? So if from here to here is 5, for me to determine how much each box is, I have to say 5 divided by the 5 boxes. So that means each one is 1. So this would be 1, 2, 3, 4, 5. Everybody see that? So that was excellent, excellent observation. So 4 hours is 8. So how much is 2? How much is 2 hours? Excellent. 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 Last one, just for the purpose. How many persons watch TV for 3 hours? Good catch back, Myrtle. Excellent job, 11. So there it is. We are capable of analyzing, and that's what we call analyzing. We just analyzed the histogram. We looked at it and we were able to pull out information based on how it was represented. So now let's get back to the matter, the juice of the question. Here it asks us to calculate some probabilities. So I am only going to do the first two, and I'm expecting you guys to try these on your own, okay? So let's go. Let's do the first. Let's see how fast y'all do it. So first one, what is the probability of 5 hours? We know probability is represented as a fraction. So what's the first thing we got to do? In your exam, men expect you to draw this over. On your diagram, what is the smartest thing to do? Over each bar, write the number. Everybody see that? So over 0, put 15. Over 1, what is 1? 1 is 18. It looks so, 18. This one is 2, we already said 3. 11. What's this? 8. 15. And so for A, what is my denominator? Somebody pull out your calculators quickly. Tell me where you get. What is the total? So some people saying 50, some people saying 70. Back check it, please. 15 plus 18 plus 3 plus 11 plus 8 plus 15. 50? Okay, Cloris, back check, okay? So 50. Somebody else says 70. Guys, come on. Please back check it again. You see why you might be confident, but check it again. So 70. All right. So 70. So let's look at what A asks us for. A is asking us for the probability that the group watch TV for 5 hours exactly. So we go for 5. So what is my answer? Guys, somebody else saying it's 50. Let me pull up my calculators. I don't fight all you know. I need to be able to trust y'all that y'all gonna add these things and tell me the right answer. So let's go. 15 plus 18 plus 3 plus 11 plus 8 plus 15. Guys, I got 70. 15 plus 18 plus 3 plus 11 plus 8 plus 15. Jeffrey, the 11 there all the time. All right, so let's keep it moving. So the first answer is what, guys? 5. What's the probability of 5 hours? 15 over 70. And you break it down because 5 could go into these two numbers. So that would give me what? 3 over 70 divided by 5 is what? 70 divided by 5 is 14. Pretty straightforward, right? B, what is the probability for 3 hours now? Let's go. 3 hours would be what? And when you make a mistake, don't get stuck on it. Just keep it moving, okay? Okay, 11 on 70, excellent, excellent. 11 on 70, excellent. 4 or more. Let's do that last one quickly, and then we're moving right along. 4 or more. Excellent. Excellent. So we are now capable of determining the probability from diagrams and also from statistical data. No, it doesn't matter what diagram is given, whether it's a bar chart, a line graph, you just pay attention to what is given, and you always have to find what? The total, and then you look at what they're asking you for, okay? So that's it with probability. How y'all feeling about it now after we completed those CXC questions? Good to go? I hope everybody should be giving me nothing less than an 8. Y'all should not be giving me anything less than an 8. Okay. All right, so now we're gonna get into something that's even more important, and this is where we're gonna After this topic, we're done. We're going to close off on after this topic. All right. So measures of central tendencies. So let me just quickly give you guys an idea of what this means. Sometimes when given data, you would get a small batch of numbers. So you would get a small group of raw data. So you would get like 1, 3, 6, 8. You might get a list like that. But let's be real. There are cases where sometimes you might get thousands of results. And when doing anything, you cannot look at each individual result separately. So in maths, there's something called mean, median, and mode. This is summarized representation of your data. And so we're going to look at what each of them mean and how each of them is useful. Y'all ready? Let me know if you're ready, because this is probably the most important part of statistics. Well, one of. It comes a lot in paper 1, and it comes, regularly in paper 2. If you get a mode median question for CXC, that means CXC was feeling really good, because it's pretty easy once you remember it. All right, so let's just look at it. What you have to remember is that usually in maths, when somebody says find my average, that means one thing. That's a specific thing. Unfortunately, they use the same word to represent these same 3 things. So you just need to remember that. If somebody say, oh, find the average of this, that's one specific thing. But in statistics, if somebody say average, all 3 of these things need to come to mind. Okay? All right, so let's take a look at what they mean. Now, before we get into this, one of the things I want you to mentally prepare yourself for, everything that we learn going to come in 2 batches. There's something called on-group data. And so there's also something called grouped data. What does that mean? Group data is where you have your table and each, just like this. Here, what we were doing before is a perfect example of on-group data. What does that mean? Every event has its own separation. So you see here, 0 has its specific number, 1 has its specific number, 2, 3, 4, 5. Everybody see that? Whereas group data, I'm just going to do it right next to it so you can see. Group data is like a range. So instead of saying 0, I would have said 0 to 5. Then I would have say 6 to 10. Everybody see what I'm saying here? Actually, it's supposed to be 1 to 5, not 0. Then you would have get 11 to 15. Then you would have get 16 to 20. And let's say this talking about goals. So here, the table would look like this. And they would ask, how much people get 1 to 5 goals? You get 2 persons. How many people get 6 to 10 goals? Let's say 6. How many people get 11 to 15? And this would be useful for things like max, distances, body weight. Everybody see what I mean? So ungrouped is when each value is represented individually, and grouped is where they are represented as a batch. So confirm if you see the difference between the two. Exactly. We're going to get into more specific details after, but for now, I just need you to understand the difference between the two, the ungrouped data and the group data. All of this is in the notes. I'm just trying to make sure y'all, which part you don't understand. It's just how information is represented. Anybody else? Let me know if I need to give another example before we continue, because this is the basic things. I don't want to continue if we don't understand the difference between ungrouped data and group data. Another example. Okay, perfect. Let me see if I have any in this document already. I think there is actually. I think that's the only thing I don't like about this is that they didn't put it in a better arrangement. Okay, perfect. 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 All right. If you were to guess, what type of data is this? Grouped or ungrouped? This table right here, just take a guess because that's the next thing y'all have to be able to do. Figure out things even if you're not 100% confident. What does this look like to you? Excellent, ladies. This is ungrouped because as you see here, 0 is by itself. So 0 has a number. 0 has 4 goals. 1 has 3. 2 has 5 persons doing it. 3 has 5. 4 has 6. So each number has a specific result. Everybody see that? So this is ungrouped. We didn't group nothing together. But look at this example of this table here. What y'all realize here? This example is talking about grams. Which one this one look like to you? So guess what the thing is about this? 3 peas weigh between 3 grams and 7 grams. That's what group data mean. It just, instead of saying 1 gram, 2 gram, 3 gram, 4 gram, they represented the information as a range from 3 to 7. So that means 3 peas weigh between 3 to 7 grams. Everybody see that? 8 peas weigh between what? 8 grams and 12 grams. You fall inside this category. So it's almost like a category. Jeffrey, you seeing it? T, you seeing it? Everybody seeing the difference? You just need to be able to identify the difference between the two. You're not going to get tested on whether something is grouped or ungrouped. You just need to know in your head the difference between the grouped and ungrouped. Okay? So let's go back to finding the mean of ungroups. This is the easier one. And I'm going to tell you the truth. If CXC bring this, it's very unlikely. This just come in paper 1. This don't come in paper 2. It's too easy. All right. How do we find the mean from ungroup frequency table? Let me go back. Let me see something here. We got to go back. Yes. So this is the formula for the mean. No, everybody went to school. So everybody did subjects. And so, you know, at the end of the term, when you get your report card, they just ask you for your average. This is the direct meaning of mean. Mean in general means the average. How do you find the average? You add up all your grades and you divide by the number of grades you get. How much people familiar with this already? Hopefully everybody is. If you are not, that's okay. But how much people know about the mean already? You should. Yeah? No? All right, so let's take a look here. No, I'm going to break down this formula because I don't want you to look at it and get overwhelmed. This is what we call math symbols. So this here's a whole formula. And 1 year, I think it was literally in some paper, they bring this and people was like, what is CRB? I never see that before. So first thing first, what does this symbol mean? This symbol means you're adding. It means to add, find the sum. Look at it here. It is named sigma. And anytime you say, you see this mean put in front of something, it just means find the sum of. So for example, if I was to give you this, what do you think this means? This means to add 2, 3, and 4. Everybody with me? So you would put 2 plus 3 plus 4. Don't let these type of things intimidate you. So your answer is 9. So this just means 9. Everybody with me? So let's break down the next part. But before so, I need confirmation that everybody understands sigma, what this symbol means. It means to find the sum. Okay. So we gotta, okay, let's keep going. So next thing now, F. F always means frequency. And we remember what frequency means, right? How many times something happened. So to find mean, this just telling you to find the frequency times X, and I'm going to show you what X means in a while, divided by the total frequency. So let's come down here. This is the worded version of this formula. So mean is equal to the sum of the quantities divided by the total number of quantities. I need y'all to write this out for me, please. Don't write arithmetic. It is understood. Just write mean is equal to, I don't know why my thing not drawing straight across. It's very wild. And put it in a box. Every time I give you a formula, please put it in a box so that it can stand out. If you have a highlighter, highlight it. If you have a colored pen, use it. This is where things like this you need to memorize. You must memorize this. Mean means the sum of quantities divided by, and you know that's what this line means. This line means to divide the top by the bottom. Okay. And this piece of information here, I'm going to tell y'all when we need it. Right now, I don't want to focus on it yet until we understand the general stuff, okay? So let's look at our first example. We have our answer. So let's see if we understand. What type of data is this, guys? Let me see if anybody remember. What type of data is that? Is it grouped? Is it ungrouped? Is it raw? It is ungrouped, but what more specifically is it? It is raw, because guess what? It's not organized in a table. And why is it not represented in a table? Because no number came more than once. Everybody see that? So numbers like this don't require a table, a frequency table. It's just raw data. Ain't in no order, ain't organized in no specific way. They just give you the numbers direct. Okay. So let's look at finding the mean. Anytime you have a formula, what's the first thing you should always do? Write the formula, right? So mean is sum of quantities over number of quantities. So what should we do, guys? What we need to do first. How do we find the sum of anything? What does sum mean? And I hope y'all have your calculators on hand. Excellent. We're going to add. So you're going to write out 13, and please write out. Show CXC that you know what you're doing. Don't just put it in your calculators and write down the answer. Show them you know exactly what you're supposed to do. And what you're supposed to do is add the numbers given. So that's 13 plus 6 plus 10 plus 7 plus 8. Somebody talk to me. Add that up for me, please. Good. And now, how much quantities do we have? This part is confused students sometimes. So you got to count how much numbers you got. This is 1, 2, 3, 4, 5. So we got 5 numbers. So let's work it out. When I add the top, do we get 44? Somebody confirm. Let's support each other. So is it 44 over 5? Let's check to see. 44 over 5. What is that as a decimal? 8.8. Excellent. So you realize we have to express this as a decimal. The average is always expressed as a decimal. Everybody with me? Pretty straightforward, right? This is simple. You remember the formula, you follow it. Let's do the next one. Evaluate the mean of the following numbers. So let's go. We add again, so mean equal sum of quantities over number of quantities. So what is my fraction? Should be looking like 17 plus 16 plus 5 plus 7 plus 1 plus 13. Let me move this over, sorry. plus 13. That's 13 plus 5 over, what's my denominator? Okay, excellent work, ladies. Excellent work. So we're going to have 64 over 7. So what's my answer when I divide 64 by 7? 9.14. Excellent. You see, you get back the answer, 9.14. Okay. Or 9.1 will also be accepted by CXC, because if you round this off to 1 dp, you will get that. No, let's look at this next color. Let me color no question. Sorry. No, this is where the thinking come in. This is where the thinking come in. Okay. The mean height of 9 choir members is 157. Everybody with me? So let's read that again. The mean of 9, so always underline information that is important. Please get into the habit of, when you get a question, highlight, underline, select the numbers or data that's important. So the mean of 9 people is 157 centimeters. Calculate the height if A, so we got 2 situations. So before I even look at what they're asking us for, how can I represent this information? Which 2 things we get? If we used to get a formula, write the formula first. So I'm going to do that. Mean is equal to sum of quantities over number of quantities. So before we even look at the question, what piece of information did they give us? Out of these 3 things, which 2 things they give us? Because now this is where we develop the thinking. So let's go. Let me see if you are thinking. So you got the mean, you got the sum of the quantities, you have the number of quantities. In that statement, they gave us 2 pieces of information that I just underlined. Which 2 did they give us? Did they give us the mean? Did they give us the sum of the quantities? Did they give us the number of quantities? Which 2 did they give us? Excellent. They gave us the mean. Everybody agree? What is the mean? Excellent. 157. So I'm just going to substitute. I'm just going to put it in. So I got 157. Sorry about that. 157. I just writing it down. Everything they give me, I can fill it in the formula. So they give me 157. What other piece of information did they give us? Excellent. Excellent. So that's the top or the bottom? Excellent. And what is that number? What is the number? What is the number of quantities? 9. So which one did they not give us? They did not give us the sum. So guess what we're going to do? In maths, whenever we have an unknown quantity, what do we use to represent our unknown quantity? Anybody remember? We always use X. X is a letter that represents some number that we don't know, that we need to find. Everybody with me? Talk to me, talk to me, talk to me. Okay, now I taught this in algebra, and I know there's a chance we're not going to remember. Anybody remember how to find X? How do I make X the subject? How do I calculate X? How do I find X? So I'm taking my time with this because I want to make sure y'all realize that in statistics, algebra is right there again. Who could tell me how to find X? When we say find x, we mean to make x the subject. We want x by itself alone. We want to know what x is equal to. Currently, x is being divided by 9. So how do I get or find x? Anybody remember? Myrtle said to multiply. Multiply by what? Everybody see what she's saying? Why we multiply by 5? And that is absolutely correct. What did we learn about calculating or finding something? We don't do the opposite. So if I want x, what do I need to get rid of? I need to get rid of divide by 9. Everybody talk to me if you remember that. This Sunday, we're going to do a lot of algebra practice. Everybody see why? So if I multiply by 9, keeping in mind, you always do the opposite. Whatever you do to what? One side, you have to do to the next side. So what's going to happen over here? We're going to cancel 9 successfully. And so what's going to happen on the next side? What's the answer? 157 times 9 is what? $1,413. So keeping in mind, what did X represent? X represented what? The sum of quantities. Everybody see that? So we were given, we have a formula that we know out of our head. The question gave us 2 things out of the 3 things. You use algebra to find the missing thing. Everybody with me? So we didn't know what the sum was, but now we know what the sum is. Everybody with me? No. Let's look at what the question asking us for. So I'm just going to come back here and I'm going to put my labels. So I know mean is 157. Sum is 1413. And number of quantities is 9. So now we got the 3 things that we need to find any given mean. Now let's look at what they ask us for. They say calculate a new mean if a man of height 169 leaves the choir. So let's move to the side here. If this is what we had originally, but somebody leave, how much was he? 169? Is 169, right? Let me just back check. If 169 leaves, what does that mean? Did the sum get bigger or the sum get smaller? So we need to calculate a new mean. 169 leaves. What would you do to find out the new mean? You always have what? Your formula, right? So mean is equal to what? Sum of quantities over number of quantities. I hope y'all with me so far. Certain things gonna change. 2 things gonna change. Which 2 things gonna change? The sum ain't gonna change and the number of quantities ain't gonna change. So instead of 9 persons, how much persons gonna get if the man leave? So instead of 9, what we gonna divide by? 8. Very good. And if we had add up all, but this amount leave, how are we gonna find the new total or the new sum? What are we gonna do with this number? And before I even do that, let me just write this down. This was 9, because this was the original number, minus 1. Everybody see that? That's how we got 8. So let's do the numerator. What am I subtracting? Which 2 numbers? Obviously, it has to be the original sum minus his height. Excellent. So what I should write here is 1413 minus 169. So what is my new height? What is the new sum that we have? I should write minus 1 in red, you know, I should do that so we could all see. 1244. Somebody divide that and tell me what we get. $155.5. Let's see if that's correct. Excellent. What do you think y'all missing from your answer? What y'all missing from your answer? Anybody realize what y'all missing? Do not ever forget your units. Centimeters. No, I want to bring your attention to something. My concern is not the answer. You know what my concern is? The thinking. What you realize I did here to calculate that. Could I have calculated this without the information now found first? Anybody realize now? Would I have been able to know, oh, let me subtract 1 from 9 and let me subtract 169 from 143. Did they give us 143? So what I want to do is bring you back to how do you know what to do in a question like this? Always start off with your formula. When you write your formula, fill in the information that they gave you. And what did we realize when we fill in the information? Which piece of information we realized we did not have? We did not have the sum. Using our maths knowledge, we know we can't calculate a change if we don't know the original information. Everybody see where I'm going with this? So anytime they give you a question and they say, find something, but then they ain't give you everything you need, it is your responsibility to find it on your own. So even if you can't do this by yourself yet, do you understand what I'm trying to show you? That's all I need to know. Do you understand what I'm trying to show you? Somewhat. Don't beat up yourself about this question too much. This is an advanced question. This is an extremely advanced question. So don't worry about it too much, okay? We're gonna do more questions like this after. So this was what I would call an indirect question. So if you look at the examples we've done so far, what would you call question number 1? Question number 1 is a direct question, in it. You just have to put a formula, calculate it, and you get your answer, right or wrong. That was direct. Number 2, direct. But what you realize about number 3 was an indirect question. Okay? Even if you're not there now, I'm just trying to introduce you to these questions from now so you can start getting used to it. So don't stress yourself too much. We're going to do a lot more of these questions coming down. Okay? All right, so let's wrap up. That's the mean. I just want to give you one more example and then, yeah. So everybody find the mean of these numbers, please. Tell me where you get. Find the mean of these numbers. You guys have 1 minute. I'll give you 2 minutes. I see different things. Find the mean. Find the mean. Again, a lot of different answers. Please back check. Please back check. You have 50 seconds to go. So each person that sent me their answer, this is the class challenge. Please back check your answer. 30 seconds. I want my answer to 1 decimal place. One decimal place. Ten seconds to go. All right, time is up. So let's take a look at what we need to do. What is always step one, everybody? What is the first thing I should write? Nope. We can't just start adding. We always write the formula. So I'm letting you know, no, please make this a habit. Write the formula. You know why? Sometimes, most times you get marks for the formula. Not only that, it is a guide. It's something to remind you about what you should do. Okay? So when I write the formula, I should write mean is equal to sum of quantities over or divided by number of quantities. Everybody with me? So let's go. Then you show your working, and my working would be 4 plus 6 plus 5 plus 3 plus 2 plus 5. All divided by how much, guys? Excellent. Excellent. What is the answer in the numerator? 4 plus 6, 10, 8, 20, 25. So that's 25. That's correct, right? 25 over 6. No, I want to teach y'all something. Just quickly. This is what we call estimation. This is a skill that helps you pick up a mistake quickly. Okay? It's very important because let's say in the heat of the moment, you're putting something in the calculator wrong and you realize and you get an answer. You should be able to look at a question and understand what neighborhood your answer should be in. When you look at this, what number is close to 6 that could go into 25 exactly? 5, in it. So I know when I divide 25 by 6, my answer should be, and this squiggly line is 25. Not 25, sorry, 5. Everybody see what I mean? It should be close to. But guess what? Why would it be less than 5? Because we are dividing by a bigger number. So you know your answer should be between 4 and 5. So if you had gotten, let's say 26 or 41, that should give you a big thing because you'd be like, oh no, my answer should never be up there. So you know to check it back over. Everybody with me? That's what we call estimating. It's very important in, as I said before, picking up mistakes. So when I divide this, how much y'all get? Let me check it. Let me check it myself. 25 divided by 6. I got 4.16666. That's what y'all get when y'all put it in the calculator. So directly, this is what my calculator give me, 4.166666. So to one decimal place, we already know what we need to do. Draw a line. This number is greater than 5, so this number is going to increase by 1. So your answer is 4.2. How y'all feeling about the mean? Pretty straightforward, right? So we're not gonna do more. What I like about this, the most important part, what is the most important part? The formula. The formula. Okay, guys, let's move on to just to show you for practice. Anybody want to practice? You got a lot of practice here. And you have some challenge questions as well. A lot of these questions are challenges. They are indirect questions. So take a shot at it, see if you can get it on your own, see if you can get back the answer. If you can't, don't stress yourself too much. No. What is the difference between this information here compared to when I had 6, 7, 8, 5? What's the difference? Here, how much times we get 0? That's my question. How many times does somebody get 0 goals? Exactly. How many times somebody get 2 goals? So if 5 people get 2 goals, how much goals is that in total? 5 exactly. So here's what, in raw data, each element is generally represented once versus group ungroup data. You see the difference between raw and ungroup now? Raw, most likely sometimes you just only get digits once, not all the time, eh? But in the frequency table, you would realize that this information is special. So let's go. Let's find the total sum of goals. 4 people get 0 goals. So how much goals here still? Let me see if anybody could figure this one out. 4 people get 0 goals. What's the total goals here? Trick question. If 4 people get 0 goals, how much goals was made there? When you're sure? 0. The answer is 0. Because why? None of them 4 people score any goals, so it's 0. You see how I got 0? Everybody, let me know if you see how we got 0. Okay. Okay, what should I put up here then? 3 people score 1 goal. So how much is the total goals here? Let's run through this. Excellent. 3. Very good. 2 people score 5. We already worked that out. That's 10. 5 persons scored 3 goals. How much goals that? Excellent. 6 people score 4. 7 people score 5. So guess what? Now we have the accurate information, and now we see why we need to apply this version of the formula. So let me just go back here quickly. Where's the formula here? So now I want to show you something. Or should I work it out first, then show you? Let me work it out first, then show you. So here, we want to find the mean of this. We want to find the mean. What do we always start off with, guys? Let's start off with that, because remember, this thing will give you your guidance. So what should I write first? I should always write my formula. Let me use black. Everybody agree? That's always step 1 formula. So what is our formula? Mean is equal to sum of quantities over number of quantities. Assume numbers will be used to find the sum. Can you hear me now? Can you hear me now? Can you hear me now? Okay, something went wrong with the mic. Let me check back on. Hello, hello, hello. What is this? What is this going on here? Don't fight. Hello, hello, hello. Hello, 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 hello. Okay, all right. So here's what we're gonna do then. I really wanted to finish at least mean, but we could end here. Y'all tell me what y'all want to do because I was asking if y'all okay. Because we did a lot. I wanted to at least finish mean. More than median is super easy. So I could always run through that quickly on Thursday and keep it moving. So just let me know how y'all feeling. Okay, so we're gonna end here. So just to quickly recap then what we've done, just to make sure we remember, and then you're gonna give me a ranking about everything you understood. So we went through the general idea of statistics. We looked at the different types of diagrams that we're gonna come across shortly. We looked at probability, and I think we were very strong in probability. We did some examples, including some CXC questions, which I think again you guys handled well. And then we went into mean. So we looked at the formula, and then we looked at some examples. And again, I think we did pretty well. So we're going to end here today. So give me a feedback for what we done today, and then that's how we're going to end class. So talk to me. Out of 10, everything we did, how you feel? 9, 9, 7, 7, 8.5. All right, 9.5. Okay. Now I'm telling you guys now, I just have to be honest. I'm gonna end tonight because it's the first time we getting back into it. But moving forward in the future, we're gonna have to push a little extra. You know why? Do you prefer to be rushing at close a week before the exam, still trying to finish, or you prefer to push now and get as much done? That's the type of thinking you need to have. Suffer now, but finish as much as you can now, so we give ourselves more room to do more revision closer to the exam. Okay? So thank you guys for coming today. I'm going to see you guys on Thursday, and we're going to continue. Remember, the slide will be available in Google Classroom, so you could read ahead if you want. I would recommend that. Read ahead so that when we come to class, you would at least be mentally prepared to learn what we're learning. Okay? So that's it for today. Have a great evening, guys. See you on Thursday, sorry.